good evening, good morning, good afternoon, good day, if I may say like that. And welcome to the new episode of the Cloud Launch and Learn. And welcome tonight. We have one more wonderful session today. And I'm happy to say that we have Niati tonight, which was 2-3 episodes ago again, and it was me. And I was really happy to see all of that is happening on Google Cloud, and I suppose everyone else was enjoying on that session. So tonight we have extension, if I may call it like that. And tonight is about the multimodal multi-agent. And basically, yeah, Niati, welcome, and happy to have you again. I must be honest.
Thank you. Yeah, let's go right into it.
Indeed. I will leave the stage. I think from last time you saw Niati, what she presented. So if somebody didn't watch it, 2 episodes ago, she was presenting something similar about Google and AI and how that works. So I would highly recommend to watch that episode. And after that, feel free to watch this one if you're not watching now. So yeah. Niati, the stage is yours. And yeah, let me add it to the stage. Yep. The stage is yours, Niati. Feel free.
Hi, everyone. My name is Niyati. Today, I'm going to talk a little bit about how to operationalize multimodal agent and model. Last time we talked about the overall architecture of building a multimodal agent. And today we will be talking about how to operationalizing it. So let's get into it. We're going to discuss about what are the core challenges that we face while building, designing, and deploying this agents and model. Overall end-to-end system architecture that we discussed last time, a little bit of it, the design pattern, the production environment for that, MLOps best practices to deploy and kind of operationalize this GenAI models and monitoring it. We're going to talk about how to optimize those strategy and then evaluate those models and agents and then real world case studies. So when you talk about production ready Gen AI agent, there are multiple complexity that we face. While building that, we can have unpredictable outputs, hallucination, and the cost that we have to cover, the user face problems while the models evolve, the capabilities that we have to extend through it, the scaling requirement while handling different requests, managing the model versioning, and while scaling the model itself. Apart from that, we have latency constraint, the lag between the user response and the LLM, that time, user expectancy of the response, and the time that LLM takes to generate that outputs. Another thing is quality assurance, that is testing the output while evaluating those frameworks and matrix. And then third thing is safety and compliance. So the critical consideration for agentic model while we plan and design are like security and credentials. We gotta take care about the data safety and their privacies. What are the data that we try to inject? Logging and tracing method, the testing method of it, and API key management. Testing and evaluation phase is all about error handling, the prompt review, the output quality of the prompt that we have generated, and yeah, the feedback collection, what comes out of the other end. When I talk about the designing and planning phase, we have two questions here. How do we make this system more robust and production ready for on Google Cloud? Another thing is, how do we make this multimodal and agents and the system and the GenAI system more reliable and scalable on GCP? The main part to consider here is the context engineering. Whenever the user gives a query, we are sometimes lacking the context behind it, and by giving the more information, management and taking care of the token optimization, there are a lot efficient output that can be generated on the other end. And while building and deploying those models, we got to take care about development of the lifecycle, the user interface, and the response time, the effectiveness of the measurement of all of this. So while we consider this 4 matrix on designing and planning phase, and we ask this important question, we can analyze what comes out on the other end. And as we discussed last time for end-to-end system architecture, um, the four things that comes into the mind is API gateway that handles the request routing, authentication, and load balancing. Secondly, orchestration layer that handles the prompt engineering, context management, and model selection. Third thing is inference engine, so the model serving and caching and batching, the response that generates out of it. Safety and monitoring, so we need to kind of take care of the output and validate it, what comes out on the other end, guardrails and the logging and performance tracking. So when you talk about this entire diagram, let's get started with it. So first is a front end. So the front end, when I talk about the system architecture, the first thing that comes into the mind is front end, through which the user interact with multi-agent systems, and that runs as serverless cloud run services. Second thing is agents. So you see that the coordinator agent that controls the agentic AI system, and those agents kind of communicate with each other to A2A protocol. And then we have third thing is a different task through which the agents are kind of connected to each other. So the runtime agent, AI agent that can be deployed on serverless cloud run services, and it can contain like the apps such as like GKE and Vertex AI agent. We can use agent development kit that provides different tools and frameworks to kind of when we want to develop and test and deploy those agents. AI model and model runtime, that serves basically an agent architecture that has a AI model on Vertex AI, and those architecture as well shows like Cloud Run and GKE on the alternative runtime. MCP servers is like basically connecting to the different tools to the agentic system. So we can have the model context protocol that facilitates the access to the different tools by standardizing this interaction between different agents and tools. So this is how the entire system architecture that interacts in between, from productionizing multimodality, um, that behaves in a multi-agent on cloud. We can cover different system design, MLOps, performance monitoring, and cost control on all those through all those components behind it. So system design blueprint is all about like how do we use the interface, AI model, agent orchestration, and tool integration behind it. And when I talk about this planner, last time as we discussed, we have different pattern and topology. We can have ingestion layer pre-processing through embedding, that gives a kind of different context behind speech to text and text to speech API for processing those diverse data. Another thing is multi model AI models. So the different agents interact with each other through Vertex AI, and to understand the content behind it and process the input. We have response generation and delivery users. So the delivery patterns that we discussed is it can be synchronous or asynchronous. Through all of these things, we want to analyze this topology, tool data abstraction, and the stack that we are using. These blueprint kind of conveys a robust architecture that have so anytime when we want to deploy and build those complex multi-agent or multi-model GenAI application on Google Cloud, we're going to focus on all of these things, including on system design, MLOps, performance, and cost efficiency. How can we make this model um, more like smooth? How can we make smooth operation for deploying those models on the system? So we can consider quite uh, two or three things here. The main focus should be, which is version control, performance monitoring, and continuous improvement. Whenever we want to kind of uh, want any GenAI system to adapt the MLOps practices. We want to understand the characteristics behind it. So when we understand the traditional CI/CD pipeline that that work on normal systems, we want to enhance that through version control, prompt versioning, we can say that, and testing of the framework A to B mainly, and automate those on end-to-end quality checks. Version control can be like task prompts, it can be like model configs and evaluating the data sets on Git. Performance monitoring is real time. We can measure through building the real time dashboard and track different matrix components such as like latency, token, error rates, or cost per request or per query that is being asked to the user. Continuous improvement is we generally want to take a system in a way that it can take the feedback out of it and build on top of it. So automating the feedback loop, it can help enhance and analyze the user query on top of the prompts and outputs that is being delivered through the system. So the cycle, how it works is we have a data, we have a model, the prompt, and we are evaluating it. So version control for data prompts, and then we have a Vertex AI pipeline through experiments. We have human loop feedback system. So as I talked about it, in traditional system we have CI/CD, but here we are enhancing it through prompts and agents. We are considering the version, everything. We are considering the human feedback loop, and other than that, data and retrieval governance and environment guardrail through it. So through all the systems you want to consider, you can see that it's mainly the prompt, the model, the data set, and the policy that you use, including the deployment strategy and the human feedback loop behind it to make the entire system relevant and deployable on cloud through MLOps best practices. And to make it more advanced through MLOps, we can consider these. Let me talk about first the diagram, how the different components correlates. So while deploying those models, we want to implement advanced MLOps practices. So what it does is it can make your uh, scaling more reliable, and we make the system more ethically deployable, and continuous improvement through the system that we are building, the life cycle from data to deployment. And let's say we have like this version control, a Git, and we are giving with the Vertex AI pipeline, we have like data, model, and prompt, all version of it. We have feature that utilize storing for consistent like feature versioning and serving, and we have the policy that takes care of the safety of the data or data configuration or safety policy in Git. We have Vertex pipeline through which we are kind of orchestrating the end-to-end workflows through GenAI, data preparation to model deployment. We have at each step we have to kind of take track parameter and artifact full experiment. So all of these things, the middle part that takes place here, we take the model, we evaluate it, and then it goes through human after giving the prompt, and human feedback kind of go through the model itself after the prompt is given. So it can the whole circulation can take place through the human. It enhance the model through human feedback, as we see here in the diagram. So we can have um, any prompt that works through the model to evaluate the system again and again each time when the prompt is given by taking the feedback from the last prompt or the information that the model has. Um, the continuous evaluation that we discussed, that can serve a major part, and we can use LLM as a judge technique to it. We want to automate this matrix by establishing those pipeline that can help us to evaluate the model performance and safety and biases. So what LLM as a judge does is it utilizes LLM model to automate uh, quality evaluation, and it generates the output in a way that has a predefined criteria that is given in the query itself. And we can monitor it by we can understand the model drift and effectiveness of the prompt that we have given in the system behavior, and we can monitor that using Vertex AI. When we talk about data and retrieval governance, there is a few points. First, we want to inject those data into the model. So we want to securely manage those injection for RAG, and we want to fine tune that on cloud storage and then BigQuery. Then comes the quality of it. So we want to make sure that the continuous monitoring of the data quality and retrieval of this accuracy for RAG systems. Then access control and end-to-end, making sure the accuracy of the model itself. Here, when I talk about end-to-end orchestration, we want to make sure different things such as staging the production environment and consistent delivery of it. We are considering different filters and responsible AI guardrails, such as like using Vertex AI safety, and apart from that, cloud logging, tracing. So each time, whenever we get the output, we want to make sure that um, instead of you understanding the whole output in the end of it, if we take the logging at each stage from from designing to planning phase, if we have the log, we can kind of easily trace what happens behind the component itself and the interaction behind it. So while we practice this MLOps practice for deployment, um, if you want to measure the performance and cost optimization, we have different matrix that we want to measure through it. We can balance speed, quality, and cost, and that makes it the cost effectiveness more sustainable while performing those GenAI operations. Strategic optimization that can reduce about in the system that has seen it can reduce the cost up to 60 to 80% while we implement those MLOps practices, and it can also improve the user experiences. So when I talk about those, we want to ensure the intelligent caching, model routing, batch processing, and prompt optimization. With those responses that we have that has been generated, the embedding that takes place. So by utilizing those common queries and embeddings, we can eliminate the inference calls, and the semantic search kind of it makes improve the system drastically. While using the model routing, we can route those simpler queries on a larger model. So whenever we have uh, complex queries, we can make it smaller by breaking it down, and that can reduce the cost minimum up to like 70%. We can batch process those entire workflow in terms of stages. We can optimize the prompt, we can compress it, and maybe make the prompt more and more efficient by removing those unnecessary or redundant information or instruction, and then take the entire prompt in a one go in order to make the output more and more efficient and minimize those tokens. And at the end of the day, we want to accomplish what we want to accomplish is performance and cost optimization. So as I've seen, by utilizing all those practices, we can kind of increase the throughput by 3x. We can reduce the cost by 70%, and latency itself, depending on what kind of specs that we have taken in consideration for deploying. We have seen that approx 200 millisecond of it improvement for latency or for deployment. Performance monitoring and cost control for Gen AI, there are different aspects that we can consider or discuss about it. First thing is the latency. So if you want to measure that this end-to-end response time that that kind of comply in a way or help us optimize the response time, the quality of data, or the overall output that we're considering that can be utilizing that can be made efficient through human evaluation process. So the feedback system that we are utilizing, user feedback and rating, and apart from that, the different matrix code that we taken out of it, safety of this entire system that measures or monitors the data or output. We can reduce the bias and make this more and more ethical. um, I would say that the attempt to use it uh, in the terms of data injection or the quality stage, that makes more and more efficient from the earlier stage itself. The retrieval of the data is also an important part of it. While using the RAG system, then whenever we want to evaluate any kind of system or relevant to the accuracy, of course, recall and precision method in chunks and the grounding score, we want to make sure that the output that we are expecting that aligns with the retrieved context. So the context provided context should kind of align with the output that is expected through the system, and through that we can make the system more and more reliable with less error, adaptable, increase adaptability, and reduce error time as much as possible with utilizing cpu memory and gpu. One of the important aspect is model and data drift management. So continuous monitoring of this data and auto remediation that helps us in cost control as well. So let's say if I want to track any changes regarding data distribution or like model embedding or output characteristics that I want to expect, I want to leverage Vortex AI monitoring for that. If I want to kind of help understand the trigger, what triggers the system, or put like any defect, sorry, detect any drift out of it, then I want to strategize the model fine tuning, retaining, and switching. And we can use those MLOps pipeline via and the different alternative models via Vortex AI model registry. The cost control strategy is, while on the designing phase, we want to understand the model selection. Let's say, as an example, we have delivery, continuous delivery, um, that is being taken care through operation of the model. We want to make sure that the model that we have selected are the different or smallest through an efficient model, so that we can measure the performance and the quality out of it. And one of the consideration is using Gemini Nano for that. And other than that, as I discussed, prompt engineering, data governance, both of these aspects can help us reduce redundant data and unnecessary consumption by kind of making the context more and more clear for designing phase. And you can make that prompt clear and concise to kind of minimize those token usage to help us cost control. Another thing is runtime optimization. So different strategies being used for runtime optimization. We can use prompt compression. That is one of the famous after batch processing. So what happens is, like, let's say we have different techniques that we are using for RAG, and we want to summarize those prompt in order to have um, understand the model, in order to provide the precise context behind the query. We want to, instead of breaking down, let's say we have 10 different prompts, we want to summarize it and put it into the feed so that the pre-token cost can be minimized by the number of the tokens that is being generated through that system. And one of the way we can do that is optimizing API calls to Vertex AI PAM API. One another thing is batch processing. So we want to kind of make sure that the same categorized task that is being taken care or leveraged through cloud functions. And the data flow that we use in this batch processing that can help us process this cost effective asynchronous processing. Model routing is kind of understanding the dynamically route different simple requests. So let's say if I have a complex request, um, in order, and the other side is a larger one. So what I want to do is I want to use those Vertex AI endpoints to make it the custom logic for dynamic model serving. So here I have like different a graph for different matrix measurement that has been used. One of them is like token usage, another is cost, request count, and latency. So you can see that the model uh, mixing, we can use like both Gemini and open source here. Batch versus stream inference, and another thing is quantization and distillations. How we want to evaluate and quality measure the assure the quality of this model. So let's say if you want to test any gen AI system that requires any kind of matrix to assess through different factors such as like safety or alignment, through different or particular business objective, then we want to consider different aspect of it. We can um, understand the user satisfaction. Let's say we have four different business objectives that we want to achieve. So these are some of the three or four main aspects is safety compliance. So we want to make sure that the content behind the screen is like less is without violation. The accuracy behind it is like it has a trusted knowledge through which the data is being injected, and it validates the claim that is being put, and it doesn't have generate the or detect the hallucination. Another thing is user satisfaction. So let's say if I want to track down any conversation or any follow-up patterns, the user must be satisfied with the workflow that the system is providing. And the relevance testing is how we want to measure those outputs, how well it is in order to address those queries that is being generated on my model. And using, let's say, a semantic similarity or user evaluation, we can make that testing more and more relevant. So when I talk about evaluation and guardrail, um, we are still sticking through this optimization process where the GenAI system means we can make the system more trustworthy and it has measurable pipelines. Um, the matrix is like accuracy, latency, hallucination rate, and cost per request. So let's say if I use LLM as a judge evaluation, and these are the three factors that I'm considering. I'm using Vertex model monitoring, and the system is kind of expecting safety for Gemini safety filters on for the content moderation side while I use that API. So if I have LLM as a judge evaluation, the safety filters, moderation API, and data drift monitoring, I can, with these four components in the matrix that I'm measuring, I can have 84% of accuracy compared to not using it. The latency with 4420 millisecond, the hallucination rate, as you can see, is drastically reduced, and cost as well per request is drastically reduced. So the main goal here is evaluating the accuracy and understanding how we can reduce the cost per query or prompt that is given to the system through user. um, I think most of the things that I discussed is all here. Input validation, um, and all of those things, runtime monitoring and output filtering. Whenever I have multi-layer safety, let's say if I have a system where I want to go through different workflows and multiple layer is connected to each other. Then to validate through those different layers, I want to make sure that it passes through the different stages of the response cycle. um, and to evaluate those safety and to evaluate this system through safety and safety, then I want to make sure that the system passes these key evaluation matrix, which has like accuracy, latency, hallucination, and cost per request. Most of those characteristics that I've discussed is we want to make sure how well the content that is being pushed through the system or generated that aligns with accurate data and it's not factual for the user content. Latency, as I discussed, the time that we want the model to generate the response, and in comparison to how fast the user is expecting it to generate, and if the system in fact receiving the prompt in those time without lagging. Hallucination rate is the number of the frequency that we are generating for incorrect and unsupported information, and cost per request is how well the cloud is uh, being able to conceptualize and build on the infrastructure while utilizing those prompt and queries through each model inference. To use these evaluation methods, we can kind of utilize different tools and observability. First thing is Vortex model monitoring. Second is open telemetry, and another thing is cloud trace. So what all these three things does is, while using the Vortex model monitoring, we want to, let's say we want to track the model through different performance metrics, such as like drift or feature importance drift in Vortex AI. Then we can use this Vortex model monitoring. When we want to standardize any collection of those traces and matrix through log and GenAI application, Open Telemetry has become more holistic approach. For cloud trace, we have monitoring. We have a monitoring through latency and performance, and each time, let's say, any model kind of request or user request through complex GenAI architecture, we want to identify those bottlenecks at each stage and optimizing it through it. These are some of the same reasoning or explainability that the factor that I have put. We want to make sure that by using those safety system through different content and policy agent, apart from that, the safety filters that we have used, it basically explains how which part of the system that we want to optimize. Apart from that, uh, how we want to contribute to the system as an LLM, so it can use as a judge or reasoning both apart. But how at the end of the day, how we want the system to behave in terms of reasoning, or we want to act the system as a judge, that is what is up to user how they want to use it, while they also monitor the data drift. So the each stage for this GenAI evaluation pipeline is, first is data ingestion, then comes prompt engineering, then model inference and evaluation matrix. All of these things that we discussed here, and all these factor is being measured through the matrix using accuracy, latency, hallucination, and cost per request. And the last part is, let's say if I want to explain a real world case study, then I'll take an enterprise customer support system where we have architecture, cost management, and safety measure, all of it. And let's say we have like any Fortune 500 company, or where we have deployed GenAI powered customer support system, and that generates, let's say it's handling a millions of queries per month basis, per week, or yeah, on each quarter. So we want to achieve the system that has like more resolution rate and that can handle via the system, context behind it, and less uh, cost, basically the cost reduction out of it. So how do we want to manage the architecture in a way that it can generate the output with the less cost, and we want to manage it throughout the query that is being generated on each month or week or quarter, and we want to measure the safety while it is happening. So let's say we have RAG, and we're going to approach this architecture hybridly using not only one model but maybe using two models, and we're going to tune it in a way that it can understand the common questions, and it has a RAG over internal knowledge base. So whenever the user feed uh, is like bombarded with different information, it can only take the context behind it, and it understand what knowledge it has like is being injected for the same query in the past. And while using those knowledge base, it becomes easier for the system to understand the context behind it and generate the output with less cost. So let's say viewing this case study, we have the design, we have the architecture of agent and modalities. It can be, as an example, text and video, and then we are deploying it through automating those MLOps practices, and to make the evaluation more and more effective. And then we want to scale it. So at the end of the day, what we want to achieve is monitor the cost, performance, and build the trust through data safety. We have the vision model in terms of this, and we want to understand how the model behaves through the dashboard while utilizing all this evaluation techniques that we have used. And while we use that, we can see that the time reduction and recall improvement, which is about 65% and 30% more compared to using traditional CI/CD pipeline. And one of the basic test case for using this kind of architecture is we can have a built-in multimodal QA assistant, and the way model interact is using different stacks. It can have Vortex endpoint, Cloud Run, and agent and pub sub services. One of the most important key takeaways that I'd like to kind of enhance here is, let's say we have a GenAI production system in engineering, and if you want to make that system combined with multimodality and agent coordination, then MLOps practice becomes the best to use it, and that can offer Google through the GCP, Google Cloud infrastructure. And while we deploy it, we are taking the three aspect to consider: security, testing, and deployment. Security in order to kind of uh, credible the data credibility, and manage those sensitive details for you of users while prompt is being generated. We want to understand the interaction behind different system and tools through which system is or tool is or agent is connected. We want to test and evaluate those methodology are being used through different tools, and understand the quality of the response through let's say feedback system or error handling or human feedback system that we have injected in that. We also want to make sure that building and deploying phase of it that can help us select the minimum or maybe the appropriate runtime to save the cost and reduce those time for development lifecycle. And using a agent to agent protocol, MCP, A2A, all of this can help us measure those effective of the system against against the time that takes more using traditional processes. How do we make sure that the system is like robust and efficient enough for production grade? on GCP. How do we make sure that this multimodal agent that we have deployed is reliable enough? So all this practices, MLOps practices, can help us kind of understand the reliability of the entire system that we have built. And once we understand the reliability, we can scale it enough on GCP. So through all these phases, we want to understand the design, um, optimize it. We're going to build it for safe. Once we optimize that, we scale it and continuously test it while it is being scaled, and help us all this phases help us understand the feedback loop, to continuously kind of refine the prompt and make the knowledge base more and more relevant to the queries, and align it if it's not, and improve the model at the end to make the business related decisions more and more effective. Yeah, I'm happy to dive in any questions for this, and yeah.
As always, very excellent presentation, Niati. I must be honest with you. And basically, yeah, so far I think we didn't get any questions from the audience, but now looking on the question that I see on the screen, or no, let's say it like this. First of all, kudos, because this was unspecific, a little bit presentation. It was not a classical PowerPoint. I must be honest, I really like it. I'm not sure what did you use, but I really like the small bars on the bottom and how do you do. So really kudos for the effort and all that stuff.
Mhm.
Yeah, for the second thing that I wanted to ask is basically because I saw also I have two questions, by the way, from my side.
Mhm.
The one is about the architecture. For example, when it comes to I read the takeaway from you. Also, I saw there is a paragraph. If you scroll down a little bit, I saw that paragraph with the architecture and all this stuff. But I'm more curious, if I may ask like that, how I design the agent, for example, if and what do I use? Let's call it like that in the real technical way to orchestrate all of this. Do you have, for example, yeah, Martin, you can start building tomorrow with this, and this, and you can start do the magic. Let's call it like that.
So you wanna ask like how to design this entire system?
Yes. For
Yeah,
example, just straightforward, if I may call it that. Martin, you use this, and this, for example.
I would say mainly get into the Vortex AI
Okay.
that can help you deploy. There are
Okay.
different tools and frameworks for that. We have different tutorials how to kind of design to deploy phase. So if you just go on Google Cloud Library, you will have find entire tutorials that
Okay.
people have built on specific use cases to deploy one system, and let's say one single agent or multimodal agent, and they have like different stages of the workflow that they go through,
Yeah.
and for the designing phase and then deploying on Vortex AI. Yeah.
Perfect. So you mean on this? I think I have seen a couple of Vertex AI agent builder. I think something like
Yeah.
that. It was.
Yeah.
That one. Okay, so I was thinking, I was not sure if it's the right one. That's why I wanted to check also with you. And my second question is based a little bit more on the security, if I may call it like that, on or on the safety policy, on those type of thing. So if I'm asked, how are we or which evaluation stack do we run, for example, Vertex AI or something else, and how do we encode, let's call it like that, the safety policies, like I don't know, prompt rules. What else we have there? Allow lists, content filters, and all of those things. How we encode, let's call it like that, in all of these agents. Do you know or do you have any observation how that can be?
Yeah, so let's say it depends on what kind of input you are taking. So let's say if
Okay.
you have a vision and text system for as a in terms of for the safety that you are considering for multimodal system. So
Yeah.
only two inputs that you are considering, let's say vision and
Okay.
text. So practically the stack that you are using is like you understand the test and matrix behind that,
Okay.
infra
Okay.
and tools.
Okay.
So in terms of content, you want to understand like image and the video that is being coming out as a content, and maybe the text. Hallucination part of it. Content is like understanding the harm and toxicity behind it. So let's say you want to filter the system through different text or the embeddings that you want to
Okay.
filter. Let's say there are some self harm or violence that is through that, so you filter the system through that particular keywords, and that help you understand the content safety part of it. Another thing is hallucination. So what you want to do is, let's say if you have a wrong description of the images, then the fabricated detail regarding the image, that will also kind of generate the wrong information out of those entire model. So you want to make sure the caption behind the system is kind of, it summarize the video as it is. So that's what you want to make sure. Another thing is the bias.
Okay.
This is one of the main aspect that you need to consider while, let's say, the stereotypical images, or maybe like gender or race, things like that, these kind of information. And while you are systematically performing those, the gaps across the system, let's say demographic attributes, so all of this behind it, bias and fairness becomes a main important aspect when you considering the safety.
Oh,
And the last part is, let's say after being built, or deploying the system, there is no misuse, and providing the exit assistant for using it, and not allowing the system, just like any, let's say there is a face recognition system or anything like that for surveillance basis. You want to make sure that is the surveillance is allowed if someone is using that, and there is a protocol behind it. So yeah, all of
okay.
it. Yeah.
Okay, okay, yeah, yeah. As a clarification, I'm just thinking cloud PQ. So if I understand correctly, yeah, the safety we have, the prompt injection, we have the bias. So all
Yeah.
of these three, if I may call it like that, as a main one, which makes sense. Also, basically the last one that you said for the assistant and all that stuff. Indeed. Okay, okay, okay.
Yeah.
Get
And
clarification. Yeah.
yeah,
Sorry.
and as a stack, as you ask for the stack, let's say you have like data set first of all that you want to take care. So different multimodal prompts through which you are injecting the system into. So it should be like, it can be real or synthetic, the image or text. Another thing is orchestrator. So you want to feed these inputs through your system and capture the input and output. It can
Okay.
be immediate calls or tool or metadata. It can have like, too simple, you can use like airflow or python harness for that,
Yeah.
that
Okay.
evaluate this inside your MLOps platform basically. And then secondly, I would say that you can use LLM as a judge. That is kind of helped you label like, if this data or whatever the output is being generated is safe or unsafe, or it is like, let's say if it is hallucinating or biased. So you want to fabricate that into your rubric, and then what are the matrix that you are choosing, let's say safety, hallucination, or bias, you want to present that into your dashboard. So whenever you are evaluating, you can measure that performance at the end of the day on your dashboard, and you can evaluate this entire system and then govern, and then yeah, feed it accordingly. Yeah.
Oh, nice. Oh, nice. Oh, that's nice. Really nice. Really nice. Thank you for this clear explanation, Niati. I must be honest with you. I really liked also the explanation, and it's more clear for me, if I may say like that. So, learning something new, of course, is more than welcome. Yeah, I don't see any comment from the audience or any question. So I usually say that means that the presenter has done a great job. So that everything was loud and clear. So here, Niati, I would like to thank you for the wonderful session, for the wonderful explanation. And yeah, I would wish to all of the people that were watching or that will watch this later to have a wonderful day. And yeah, we will see each other on the next episode. So yeah, thank you all, and see you next week with some new episode. Bye bye.
Thank you.
Bye.